Hello there, and welcome to Unit 4. This is a section about triangle incongruence. And I really like triangles, specifically right triangles, but we'll get into that later. So let's kind of talk about a few things here. Let's talk about section 1, and this is about triangle angle theorems. So in every triangle, there's some relationships that happen, okay? And so what we want to do for our objectives today, we want to be able to prove that the sum of the angle measures in a triangle is 180 degrees. We'll do that at some other time, not on the video, but we'll do that in class. And we also want to identify and relate the interior and exterior angles of a triangle. And we want to calculate the measures of interior and exterior angles of a triangle. So what I have here is I have the triangle sum theorem. And what that means is that the sum of the measures of the three angles in a triangle is 180 degrees. So all angles in a triangle add up to 180 degrees, okay? If there is one thing that you will come out of this class learning, it is this, okay? Maybe you already knew that, but that's just something that we will talk about, and we'll actually prove it and go through all that kind of stuff. But let's do this real quick. What it's saying in this, it says use the triangle sum theorem to find the value of x. So what I know is that if I take angle E plus angle D, okay, plus angle F, if I add all those angles up, I get 180 degrees, okay? Now, if I were to sit here and say, okay, well, let me add these together. Let me add 67 minus x. So let's plug those in. So 67 minus an x plus 3x minus 1 plus 5x minus 40 is equal to 180, okay? And if we combine like terms, we get 5x and 3x give me 8x minus an x gives me positive 7x. And then if I were to take 67 and then subtract 1, that'd be 66, and then minus 40, that'd be 26. So plus 26 is equal to 180. And if we wanted to solve this equation for x, we would just take and subtract both sides by 26. Okay, and then I get that 7x is equal to 154. Okay, and if I divide both sides by 7, okay, then if I take 154 and divide it by 7, that's going to give me that x is equal to 22. Okay, so the point of all this is to not only be able to figure out the missing angles of a triangle if you're given two of them, but to also be able to set up an equation and solve for x. Okay, that's pretty important that you'll be able to do that. Okay, so now what it wants us to do is it wants us to calculate each interior angle measure here. And so what I know is that if I were to take angle A, okay, plus angle B, plus angle C, then that would give me 180. Now what I know about angle A is that's a right angle. So I know that that's a 90-degree angle. Okay, if I were to take angle B, I would just add 4x to that. Okay, if I were to add angle C, then that's going to be plus 7x minus 20. Add all those up, and that's going to give me 180. All right. So now if I were to take, say, 7x and 4x, or 4x and 7x, and add them together, that's going to give me 11x. Okay, and then I can take 70 and add negative 20, and that's going to give me positive 70. Add those up, that's going to give me 180. So if I subtract 70 from both sides, then that's going to give me a value of 11x is equal to 110. Okay, if I divide by 11 and divide by 11, then I get that x is equal to 10. Okay, so the value for x is 10, but it doesn't want just the value for x. It wants me to calculate each interior angle measure. And when it says interior angle, let's before we do anything, let's come up here. Let's write this vocab word up here. We've got interior angle, okay, and that's angles inside the triangle, okay? So that's angles inside the triangle, okay? And an exterior angle, and we'll talk about that, but that's outside the triangle. Exterior angle, that's angles outside the triangle, okay? And that's it. Okay, so if it's asking for the interior angle measures, it's asking for these angle measures here. Now, what we already know is that, let me write this out here. We've got angle A is equal to whatever it is, angle B is equal to whatever we've got, and then angle C, okay? Now, angle A we already know is 90 degrees because it tells us, okay, and it has that symbol for a right angle. Okay, angle B, okay, it has a value of 4x. Okay, so when that has a value of 4x, I'm going to plug in 10 for x, okay, and that's going to give me a value of 40 degrees, okay. Angle C is also shows, what are we doing here? 7x minus 20. Okay, so I've got 7 times 10 and then minus 20. Okay, and so what is that, 70 minus 20? That's just 50 degrees, okay? So if I were to take, if you wanted to check this, okay, and this is done, but if you wanted to check and make sure that you're correct, take 90 plus 40 plus 50, and do you get 180, okay? And that's the question. You can always check yourself if you're right, okay, if you get those values. So, and we are right, okay, it is going to be 180, and that's that. Now notice that in a right triangle here, okay, notice that angle B, we knew that angle B was 40 degrees and angle C was 50 degrees. Notice here, so notice that angle B plus angle C are complementary. So in a right triangle, because this is 90, okay, the other two angles are going to add up to 90 degrees. The other two angles are complementary. So in a sense, you don't have to always add them up to 180. If you have a right triangle, which is my favorite type of triangle, by the way, then you know that the non-right angles are complementary. Okay. All right, let's talk about something else. Let's talk about the third angles theorem. Okay, and so it says if two angles of one triangle, okay, are congruent to two angles of another triangle, then the third angles of the triangles are congruent. So let's kind of show how we get that. Let's kind of prove that for a second. If I were to take angles A plus angle B plus angle C, if I add all those angles up, it's going to give me a total angle measure of 180 degrees. Okay, and so then, what I can say is that angle D and E, or I'm sorry, DEF, angle D plus angle E plus angle F, okay, if I add all those up, I'm going to get 180 degrees as well. Now, what we know is that angle A and angle D are congruent, okay? So these are the same thing, okay? These are the same, okay? Therefore, and then also angle B and angle E are congruent. These are the same, okay? So that means that in order, if you're taking these two things and adding these two things together, separately, if you look at C and F, in order for these two to give you the same thing, then what you have is that you have that angle C is congruent to angle F, okay? Which is kind of hard to see, but we can go over that further in class if we want to. But angle C is congruent to angle F. So if you have this picture where you know that these two pairs of angles are congruent, then you can automatically assume that the third pair of angles are congruent, okay? All right, let's move on. On here, and we've already kind of talked about this, interior angles are angles on the inside. So angles on the inside, okay? And that would be like angle A, angle A, angle B, and angle C. Those are the ones on the inside, okay? Exterior angles are angles on the outside. So angles on the outside. Okay, now it's kind of hard to see that because you're like, wait a minute, where do I have angles that are on the outside? Okay, I don't really see anything, okay? But if I were to take a triangle, okay, a very similar triangle, and we'll call it angle, we'll call this, point D, E, and F, okay? First of all, we have to extend these lines out, okay? If I were to extend out this angle here, okay, then this angle here would be an exterior angle, Okay, now I had to create that. Okay, it's a little bit tricky. Okay, and you could sit here and you could, extend out, say, a line like this. Okay, and this angle here would be exterior. Okay, not saying that these are congruent, just saying that these are exterior. I'll just make sure that these aren't congruent. Okay, and then if I were to extend out a line here, okay, if you were to continue this line and just extend it out, then this would be an exterior angle as well. Okay, so they're on the outside, but you have to extend out the lines first. So it's important, es muy importante to extend the lines out to get exterior angles. Okay, so that's that. Okay, I wanted to make sure we talked about that. We knew what those were. Okay. Okay, and the reason why these are so important is because, we know about exterior angles. Here's an example of exterior angles. Here's a non-example. Now remember, you have to just extend this line out. Okay, if you extend this line and you stop and you go in another direction, you're not really getting an exterior angle. Now what I know about these is that these exterior angles are supplementary to its interior angle. Okay, which means that they add up to 180, add up to 180 degrees. Okay, so now what I can do is I can sit here and I can say, all right, well, here's this angle here. All right, here's this angle. That's the exterior angle. Okay, and then I have its interior angle. Okay, and notice that these two angles form a straight line. They form a linear pair. Okay, so these are supplementary. All right, so it's really easy to actually calculate the exterior angle if you know what the interior angle is. Okay, now there's a theorem associated with this. Okay, and what it says is that the exterior angles theorem is that the measure of each exterior angle of a triangle equals the sum of the measures of the remote interior angles. Okay, so let's kind of show how that works. So here's your, and let me do this. I'm going to write in here. This is your exterior angle, okay? And these are the remote, okay? These are the remote interior, okay? So angles D and C. Now here's what I know, okay? If I were to take angle angle B plus angle D plus angle C, okay, if I add up all the angles in this triangle, what I'm going to get is I'm going to get 180 degrees, okay? Now, the other thing is that if I were to take angle B, okay, which is this angle in here, the interior angle, plus its exterior angle, and I'm going to call that, plus angle ABD, okay, I know that these two angles form a linear pair, which means they add up to 180 degrees, okay? So this is equal to 180 degrees. Now, because you're taking some angle here and adding it to angle B, plus these two angles here and adding them to angle B to get 180, to get the same thing, what we can conclude is that angle ABD is equal to the sum of angle D and angle C, okay? And this is the exterior angles theorem, okay? And that's the idea, okay? So if we look over here, it's going to ask us, okay, well, what's the measure of angle XFE? Okay, what's this angle measure right here? And I don't know what that is unless I find the value of K. So let's think about it. But this is an exterior angle right here, and these are remote interior angles. So I know that if I were to add these two angles together, it's going to give me this angle. So let's set up an equation, okay? We're going to say that 3K plus 30, so 3K plus 30 is equal to 95 minus K, okay, this angle right here, plus 2K minus 5. So then plus 2K minus 5. All right, so now let's solve this for K, and then we'll plug it back in to find out what that other angle measure is. So I'm going to do 3k plus 30. Let's combine like terms here. I've got 95 minus 5. That gives me 90. And then negative k plus 2k is going to be just positive k, so plus k. All right, so then what I'm going to do is I'm going to subtract k from both sides. Okay, and that gives me 2k plus 30 is equal to 90. And if I subtract 30 from both sides, then that's going to give me that 2k is equal to 60. And if I divide by 2 and divide by 2, I'm going to get that k is equal to 30. Okay, so I found that the value of k is 30 by setting up an equation, but it wants me to find the value of angle XFE, this angle right here. So what I know is that angle XFE is equal to 3k plus 30, but let's plug in 30 in for that value of k. So I've got 3 times 30 and then plus 30. Okay, and that's going to give me 90 plus 30, which gives me a value of 120 degrees. So angle XFE has a value of 120 degrees. Okay, and that's it. Okay, here's the other thing that I know. Okay, analyzing relationships between interior angles and exterior angles of triangles. And we have this theorem. And what this theorem says is the exterior angle inequality theorem. It says that the measure of an exterior angle, like angle 1, is greater than the measure of either of the two non-adjacent interior angles. So what I know is that the exterior angle, angle 1, okay, this is my exterior angle, okay, and then angle 3 and angle 4, these are the non-adjacent, so I'm going to say non-adjacent interior angles. Okay, we can also call them remote interior angles. But the non-adjacent interior angles, what I know is that if I have an exterior angle, I know for a fact that angle 1 is going to be greater than, okay, angle 3. All right, let me put these in here so I know which ones I'm using instead of the less than or equal symbols. Okay, and I know that angle 1 is going to be greater than angle 4. Okay, and that's it. That's all we're doing. So I hope you enjoyed this video. You know, go ahead and make sure you take your notes and make sure you get started on your other stuff. So I hope you enjoyed it, and we'll talk to you later. Okay, bye.